Assalamu alaikum warahmatullah. We are going to discuss an amazing topic of physics. It is force between two parallel current carrying conductors. Right? We are in class 12 of physics. Unit is magnetic effects of current and magnetism. Right? We have to show the fact that if we have these two parallel conductors, right, through which currents are flowing, then these two conductors will come closer to each other, means that they will attract each other, or they can move away from each other, means that they will repel each other. Here I have shown we have two conductors, this conductor mn, and next conductor xy. They are parallel to each other, separated by distance r, right? Like two currents I1 and I2 is flowing through it, right? This is the thing which I have written over here. Now let us take this conductor Mn, and we know whenever electric current is flowing through the conductor, magnetic field is developed around it. Like this is the conductor through which current is flowing, and so the magnetic field gets developed around it. Okay, that magnetic field is given by, I will write magnetic field around this Mn at distance r is given by. This is the conductor through which magnetic field gets developed. Like I would write like this. See the conductor, and around it is the magnetic field. Okay, let I am going to see this magnetic field due to this conductor at over here at distance r. Important to understand. This is the conductor, and this is the conductor. Around it the magnetic field gets developed. Okay, we know it gets developed around it in concentric circles at some distance, right? And we are going to take it as magnetic field at distance r, meaning over here, right? That relation is given by, let this magnetic field is denoted by b1 is equal to, that is mu naught by 4 pi twice the current around through this conductor. What is the current through this conductor? It is I2 divided by distance at which this is to be observed. We are observing it is magnetic field at distance r. Here it is. See, this is the magnetic field produced due to this current carrying conductor, but at distance r around this conductor. Okay, this v1, right? Now see, this magnetic field around this conductor, the direction of it will be given by this right hand thumb rule. See, this magnetic field, it will act here by this law. It will act by these fingers. The direction of this magnetic field will be given by the direction of these curly fingers, right? So this magnetic field, if we will take this magnetic field over here, it will be tangentially like this. If we will talk it over here, it will be tangentially like this. If we will take this magnetic field at here, it will be again then tangentially like this. I am going to take the magnetic field at this point. So this is the magnetic field produced by this conductor. Okay, and this magnetic field relation is given by it. So this is magnetic field b1. This is also b1. This is also b1. But we are discussing only the magnetic field at this point, right? So this is the magnetic field b1 produced around this conductor at this point. Okay. Now let's take this conductor, okay, and through it current I2 is flowing. This is the magnetic field B1, but this magnetic field is of this Mn, because we observed this, that magnetic field is developed around it, and this it is magnetic field acts upon this conductor at this point P. So this B1 is the magnetic field, but it is the external magnetic field, meaning the magnetic field from this conductor. Okay. Now, what are the three important things acting upon this conductor? First, we observed this that current I2 is flowing through it, meaning current is flowing through it, and magnetic field also now acted upon it. This is the B1. It is not its own magnetic field; it's the magnetic field due to this. But here it is magnetic field B1, right? Now, two important things, factors act upon it. First one, it is own current, and next the magnetic field, right? And we know by that Fleming's right hand rule, when there is current and magnetic field acting upon a conductor, then the force is developed. And if we apply this right hand thumb rule, and we know that this finger, if it indicates direction, right, let me keep it like this. If this index finger, it indicates direction of magnetic field, this finger, central finger, gives direction of current, okay, then the force gets developed upon it. Now let us apply this right hand thumb rule over here. See, this is what, current, and this is magnetic field. Okay, see, let me apply it like this. See, I have to show it like this. Magnetic field, this is the current. Okay, see, let us use it like this. Sorry, for it we are using left hand thumb rule. Sorry, not the right hand thumb rule. Right hand thumb rule is used to give the direction of magnetic field around the current carrying conductor. Okay, but here to give direction of force which gets developed upon this due to current and magnetic field, that is given by left hand thumb rule. This index finger, which denotes magnetic field, this central finger, it gives direction of electric current, and this gives the force which gets developed, experienced by it. Okay, so let us apply this over here. See, this is direction of electric current, means this finger gives direction of current, this gives magnetic field because it acts inwards to the board but perpendicular to plane of the board. Then this is the force, this finger gives direction of force, so this thumb acts in this way, meaning like this. So this is the force that as denote it by F2. Okay, so this is the direction of force, meaning the force is directed towards this. Okay, see, I have written it for the next conductor over here. Now for conductor XY, this magnetic field B1, this magnetic field B1 by this. Okay, here it comes. Uh, Field B1 at point P plus it is the magnetic field from this plus the current plus its own current, that is I2, its own current is I2. Okay, will develop the force F2, this force F2 on XY, which is given by the relation of the force. We know it is F is called IBL sine theta. In the previous topic, the relation of the force by current and magnetic field is given by F is called IBL sine theta. Here I means the current, it is current, not current of this, because but it is own current, that is I2. B is an applied magnetic field. What is the magnetic field applied? It is the magnetic field from this conductor which acts upon this. Okay, then that is B1 magnetic field, and it is length and theta. Theta is the angle. Here, theta is the angle. It is 90 degree. It is 90-degree angle. So by using angle 90 degree, and let us take the length of this conductor only 1 meter. So it is 1 and it is 90. Sine 90, it comes to be 1, and length is also 1. So these two, by values of 1, we will get only F2 is called I2B1. So this is the force which gets developed upon this by magnetic field B1 and its own current I2. And by left hand thumb rule, we observed that it is directed towards this conductor. Okay, so this is F2 is equal to I2B1. Let this be equation number first, and this is equation number second. Let's use this value B1 over here. See, by using first second we get this equation, and by recombining it we will get F2 is equal to this equation, and this is the force F2, right, acting upon it. And by left hand thumb rule we observe it will act, it will give it direction towards this conductor. Okay, now let us follow the same procedure for this conductor. Okay, and the magnetic field due to this conductor will act upon this. Okay, by reversing, by keeping the same phenomena, same procedure for these two, and reversing the procedure, meaning we have to take it is magnetic field working upon this conductor, then this conductor will experience the same force. Okay, that force will be given by F1. Okay, by the relation this. Okay, and this force will act, if this force was acting to this direction, then this force will act to this direction. See this, it will be F1, which I have written here. F2 will act towards this conductor, and F1 will act towards that conductor. Okay, meaning they will come closer to each other, and which is a sort of attraction, right? But this was only for the conductors in which the currents are flowing in the same direction, right? But if we take the current in opposite direction, meaning I1 is moving from M to N, and I2 will move from Y to X, meaning downwards, then it is clear that they will repel each other, which we can prove easily, right? Now we can define ampere from this problem. We observe the relation F1 is equal to this. In order to get the definition of ampere, meaning 1 ampere, we have to use those values such that we will get the current of 1, like this. I have observed here, got here I is equal to 1 ampere. How we got this current I is equal to 1 ampere? We have to use different values in order to get I is equal to 1. How we can do it? See, we know that its value is mu naught by 4 pi. Its general value is 10 to the power minus 7. In order to compare this with these, we use this as I1 is equal to I2 is equal to I ampere. Simply, distance is equal to 1 meter. Let these two conductors, they are separated by distance 1 meter. Okay, and in order to compare this thing, we have to use the mathematical sign that to get I is equal to 1. By that, for that we use F1 is equal to 2 into 10 to the power minus 9 to get value of 1. See, I have used this F1 value as this, and its value we know is simply 10 to the power minus 7. Its value here it is 2, and I1 I2 it is I square, meaning I and I. It is I, it is I, it comes to be I square, and then by solving it we got is equal to 1. So how we got current of 1 ampere? Simply, it is only when the two conductors are separated by a distance of 1 meter, simple, and the force between them got developed as 2 into 10 to the power minus 7 Newton, right, by this value. Okay, now let us write down its definition. Thus 1 ampere is that current which when flowing through each two parallel conductors, okay, placed in free space, the conductors to be placed in free space at a distance of 1 meter. We used the value of 1 meter in the previous calculation to get 1 ampere of current. Here it is written distance of 1 meter from each other produces a force of 2 into 10 to the power minus 7 Newton, which we used in the previous on the previous board to equalize the factors. Okay, this per meter of their length. So when the force of this amount is developed between two parallel conductors placed at a distance of 1 meter, then at that time the current through each conductor, each parallel conductors is said to be 1 ampere. Okay, so this was all regarding this interesting topic. Hope you may have got this topic easily, but in order to understand this you will have to repeat the topic. Thank you. Assalamu alaikum.